to find the limit here, we're going to use the limit laws. The first thing I want to do is I want to make sure that the denominator is not 0 at this actual value. Because if it is, then I've got to go ahead and do some factoring to get a new function in which I can evaluate the function by direct substitution. So let's check. If I take 1 and I plug it into the denominator, I'm clearly going to get a value of 4 here, not 0. So we're good. So what I'm going to do is I'll apply my limit laws again. Okay, so we're going to say that the numerator is the limit as x approaches 1 of x to the third minus the limit as x approaches 1 of 3x squared plus the limit as x approaches 1 of 14x. And our denominator is the limit as x approaches 1 of x to the sixth Okay, so we get all this, right? Now let's keep following our limit laws. Okay, I can take this and use the product rule 3 times and the identity rule once to get the following. So the limit as x approaches 1 of x, and I've got 3 of those guys, right? So multiplying those guys together 3 times, so I'll Q it. Minus, here this is going to be 3 times the limit as x approaches 1 of x, that guy, squared, plus 14 times the limit as x approaches 1 of just x. And then that's going to be over the limit as x approaches 1 of x to the sixth. Okay, I guess I'm going to have 6 of these guys when I expand that out. And then here, this is going to be plus the limit as x approaches 1 of x to the third, plus here, this of course is going to be our constant rule. So this right here we know is 1, so we have 1 to the third minus, now this is going to be 3 times 1, and this will be 14 times 1 over 1 to the 6th plus 1 to the third plus 2. Okay, and if we just go ahead and keep computing that, we should get 12 over 4, which is 3. So what? Well, why not just plug in the value 1 into each of these? Again, we can only plug the value 1 in if this function is continuous. And so a function is said to be continuous, and I'll do this again in the next video, but a function is said to be continuous if the limits of the function as it approaches some x naught of f of x is actually equal to the function evaluated at x naught. So a picture version of that is this. It says that if, so here's x naught, here's our limits, f of x naught equal to L. What it's saying is that if your limit approaches the same number as the function height at that point, then your function is continuous at that point. Okay, I'm going to go ahead and talk about it in the next video as well.